Okay, so just as a bit of introduction, I am going to be trying to use compute shaders in OpenGL to render like some particle stuff. I wanted to use Vulkan, but I figured it would be a lot less hassle to just get OpenGL working. This is my first time actually using compute shaders, so but I have like a bit of a scaffolding set up, just like to open a window and load some shaders and stuff, because I didn't want to be wasting time getting that working on this stream. Okay, first thing I'm going to do is make a nice background color. Okay, so hello, Charlie, what's up? Okay, so first thing I need to do is I need to create an image buffer and then write to it in the compute shader and then render it to the frame buffer using a rectangle. So I have a compute shader. I'm gonna set up an image that I can use. So all my API knowledge has fled my brain right now. So okay. So I need to do generate a texture, and then I'm gonna, I think there's text storage 2D will let me make it just blank without putting data in it. So target will be texture 2D, levels will be 1. Oh yeah, I need a bind texture. Okay. I should have had more of this working, I think, before starting, but hey DJ Microbeats. Welcome to the stream. Okay, so text storage 2D. I'll just do text image. Just quick and dirty, make let's just say I'll do 800 by 600. So I'm gonna make this be just a regular 32-bit RGBA buffer. So let's just fill it with zeros. You know what? I'm just gonna make this be a single channel texture for now. So let's just fill it with zeros, 800 by 600. And I'm just gonna do 32-bit ints. So text image 2D takes level 0, internal format is red, I think. Then width 800, height 600, border 0, format GL red. Okay, so I think I need actually the more specific formats. Yeah, internal format, I'm gonna do R. Is there R32? R32 UI, that's what I want. Okay. Okay, and then data finally. Oh yeah, type needs to be GL unsigned int, and data will just be image as pointer. Let's see if that compiles. So bind texture. Oh, I don't think I need to bind texture for that. Oh, it's GL texture 2D. Okay, I need to specify the texture. Hopefully it won't be much longer until I have actually things on the screen. As okay, so I need to cast it to a void pointer so that GL will take it. Here we go. Okay, so I have a texture. Filled as zeros. It is a one-channel texture, and I need to bind it so that my compute shader can use it. Okay, so I'm loading a compute shader that right now is just blank. So this needs to take in a uniform for that image so that it can write to it. So let me look at this. I had a image load store shader example here. So just uniform, and I had another one here. Yeah. Look at this shader. Here we go. Okay, so uniform layout RGB 32F image 2D image. So what I'll do is uniform layout. It should be. Okay, we have all the layout types here. So the one that I want is R32 UI. Yep, okay. So layout R32 UI. This is the single channel 32-bit int texture. Oh yeah, okay, I should check chat more often. Okay, so Charlie asks, assuming I'm an idiot, is a compute shader the mining Bitcoin or GPU stuff or the fancy Minecraft shader stuff? I think that a lot of the mining Bitcoin stuff wouldn't bother with using a graphics API like OpenGL or Vulkan, and they would just use CUDA or OpenCL, which are effectively let you write C++ or C and run it on the GPU. But you can do pretty much the same stuff. Like largely the structure is the same with writing a compute shader. Like it basically just gives you access to, you schedule a compute kernel on a bunch of GPU threads at once. And then the rules for what memory you can access and how you synchronize things are largely the same. Using CUDA is nicer because you can have like, it's just better for kind of structuring large scale programs. Like it's better at reusing code and stuff. But there's no reason you couldn't use a compute shader to do the same things. But yeah, it would be more likely to see a compute shader in a graphics context for doing fancy things like, I don't know, like cool lighting stuff that doesn't fit the classical rendering pipeline. Okay, so where was I? I was trying to declare the uniform for accessing the image from the compute shader. So how many? Okay, so I have layout image 2D. Let's see if this compiles. I have it set to panic if the shader doesn't compile. Cannot apply layout R32 UI to image type. That's sad. Why is that? bindless image? Do I need it to be a... Will it work if I use a sign in? Because nothing on the image load store docs says that I can't do that. Let me just try R32F and see if it works. Yeah, okay, we're fine. So I'm just going to use a floating point texture. I'm hoping, my plan here is to use, so what I want to do is spawn a thread for each particle and just have a ton of particles and have them all just additively splat their values into the texture. And as far as I know, you can only use the atomics with ints. So even if it's a float image, I think I still need to use integer atomics, but I think that works. Okay, so I have a texture. Let me just, I'll see if anything goes wrong, because this is a 32-bit floating point and this is 32-bit unsigned integer. I'm gonna see if it lets me get away with this. Okay. So I need to bind texture, and then I need to set the uniform to be that texture. In the uniform 1i, image location 0, and GL bind image texture. Okay. I've been like not talking for 6 months, and now I'm talking more than usual. Okay, GL bind image texture. Oh, what's a uniform? Okay, so the general paradigm of GPU programming is you have a shader or a kernel, which is a small program that you write in a shading language, and then it gets spawned many times in parallel, kind of automatically managed for you. And some data, you need to provide inputs to it. Sometimes you want each thread to have a different piece of input, and sometimes you want them to all have a shared single parameter. And that's what a uniform is. It's because it's uniform across all threads. So in this case, all of the threads are writing to the same image, so I'm providing the image as a uniform. So I need to bind image texture, and it takes the unit, unit 0. Unit is like, there's a set number of image units that the shaders can access. And then the texture is text. Level is 0. Layered. I don't want layered. Or maybe it's 0. Access. Okay, so I want to be able to write to this texture, so I'll use GL write only. And then finally, format should be GL R32UI. I'm hoping this doesn't cause problems like I mentioned before. 6 arguments were supplied. What am I missing? Unit texture level, layered layer access format. Oh, after layered, I need a dummy value for the layer. All right, so we have bound the image texture. Now let's see if we can just do dispatch compute, and let's just dispatch 1024 for fun. And it's so in compute shaders you get like when you specify how many threads you want to spawn, you can spawn like it's like a cube of threads. Like you get the x dimension, y dimension, z dimension of threads. And you don't have to use that. I think you can just use one of the dimensions, but okay. So everything is good. I don't know if anything's happening yet. But so I'm gonna write to this image. I'm just gonna have every thread write the value 32 to the top left pixel and see if it goes okay. So image load store is what I care about. So let's go to the image load store docs and image store. Okay. And let me look at this example that I have open. Coords are a 2D vector, and then we have a value to store. And it always has to be a vec4, I guess. Okay. Image store to the image. Some dogs barking. Okay. So Peter asks, what's the meaning behind the different thread dimensions? Like, is doing 1000x threads? So it's functionally the same in terms of how many threads get spawned. I actually don't know enough to say deeper than that. I think it has to do with, so the thing that matters is kind of like all your threads are not completely independent. Groups of threads get run in thread groups, and they share some memory. So I think that the 10 by 10 by 10 thing would have a different work group size than the 1000, but I'm kind of new to this still, so I could be a bit wrong. And then let's just store the value 32. 32 because it's a float. Okay, doesn't like that. Unable to find. Oh yeah, it's got to be a vec4. I think that's so that it can work with like a 4-channel color texture, even if what you're doing is a single channel texture. Okay, so no crashes yet. I think I'm gonna forge ahead and just try to draw this texture to the screen using a fragment shader, because that's what we'll want eventually anyway. So let's call this program draw, and then what we need to do is here, after I'm clearing, I'm gonna use the program. What I need is just a simple vertex buffer and index buffer. So let me make a new shader for the vertex and fragment shaders. And hopefully I can just get these working quickly. I'm gonna open another example I have to copy paste from. Okay, so version 460. Hey, Loney. Yeah, Russell says he thinks that all it does is just convenience index computation, which makes sense to me. Yeah, I think work group size is specified in another way. So vertex shader, let's write our color. We don't need that. All our colors are white and black based on the texture. So all we need is UV. We're going to have 4 vertices in the corners with UV values at 0, 0, 1, 1, so they can read into the texture based on that. So in UV, that's a 2, yeah, just 2-dimensional. Okay. I think this is all we need. And then we also need to write our GL position. And let's just set it equal to, let's just have a position and our UV. So in so we need our, okay, this should work. And then we'll make a fragment shader that just does it's just going to read the single channel value in the texture and then make a color from black to white based on that value. So back to VUV. We need to write out our and it's got an out. Oh, I did the inputs to the vertex shader wrong. It's so I'll just call these position UV. And then our fragment shader, like the compute shader, needs a uniform for the image because it's going to read from it this time. So when we bind it, we are going to bind with read-only instead of write-only. After this dispatch, I think we need a memory barrier because we need to tell OpenGL that we have to wait for all the writes to finish before we can let the next stage read from that texture. So GL memory barrier. And yeah, everybody feel free to keep asking questions if something is not clear. I don't know everything about what I'm doing, but I can try to answer. Okay, so I need the shader image access barrier bit. So let's see if this compiles. Okay, so at least it compiles. So now we can use our draw program and we can, I forgot, I need to give this shader a uniform. So uniform 1 UI. Just gonna copy from this example. Uniform 1I. It's 1I. So we're setting uniform 0 to image 0 here. So let's do the same thing here. And then we need to create our vertex buffer and index buffer. So I gotta make a vertex struct. I really should have set up more of this before streaming, unless people find this interesting. Hey, John. I was hoping by a half hour and I'd have more pretty picture to show. So let me make a vertex struct. So our vertices will just have UVs and positions. And they're just two-dimensional because we're just drawing a flat quad to the screen, so it doesn't need to be any more complicated than that. So set up our positions and UVs. Okay, so position is going to be in the range from -1 to 1, 1. And then UVs are going to be in the range from 0, 0 to 1, 1. So I'm going to make these vertices go counterclockwise around the rectangle. So and then same thing with the UVs. So 0, 0, 1, 0, 1, 1, 0, 1. Let indices equal 0, 1, 2, 0, 2, 3. So the reason for that is I have 4 vertices counterclockwise, and then I have 6 indices making a triangle like this, and then a triangle like that. So I need to, let me go copy paste some of my vertex buffer code. Okay. GL draw elements. Wrong code base. This has a more simple example. Okay, so I gen vertex arrays, find vertex array, and then I need the vertex buffer and index buffer, and I need the vertex format. So let me just copy paste all that. So this all needs to be in an unsafe block. So let me declare variables for my vertex buffer and index buffer. I think we can mostly use this unchanged. But these are just floats rather than integers. But otherwise, I think I can use it unchanged. So this is my vertex and index formats. And then I just need to call draw elements after I use the program. So triangles, indices.length. It's, yeah, let's just keep it at 16-bit indices. Just copy paste mistakes. Oh yeah, so I have this nice offset macro, which I think is technically undefined behavior as it stands. Correct. I'm not in Python. Okay, so what I'm using the Rust programming language. Rust it's a systems language, similar to C and C++ in kind of what it's good for. So things where you need kind of more like control over the machine and like access to memory, control over how you use memory. Rust is a good choice. Whereas it might be a bit harder to use Python for something like this. Okay, so this, let me explain what this macro is. So basically, I need to tell OpenGL that my vertices have a position value and a UV value at a certain offset into the struct. So offset just takes a pointer to the field relative to the null pointer, and then takes that as a number and can pass that to OpenGL. Okay. Finally, let's see if I passed in the image correctly. So I need to set the output color. Let's see if I just am calling my shaders correctly in the first place. Okay, I'm not. So what I do in this case, I'm not sure exactly what I did wrong. So I'm going to take a program called RenderDoc, which is a graphics debugger, and I'm going to run my program from it, and that will let me, it lets me just inspect what draw calls I made so that I can okay. Apparently I'm not making any draw calls. It's just confusing. It's not working. Don't know why. Usually this just works. So I am clearing the screen. If I comment out the clear, then I just have a black screen. I'm just going to make sure this is happening repeatedly instead of just once. It is. So yeah, I am calling the draw call every frame. I'm not sure why RenderDoc is not capturing. It might honestly be OBS. It might honestly be streaming that is messing this up. Not totally sure. Anyway, I'll just forge on and try to debug it without that. So let's make sure I'm setting my position correctly. So position is being set to my... Oh, you know what? I am very stupid. I am using an empty string as my shaders. I'm not even loading those shaders in the first place that I wrote. not sure what I copy pasted wrong. So let's just try again. So this is the vertex shader, and then now we need the fragment shader. Okay, work this time. Now our shaders failed to compile, which is better than where we were before. Alright, so now we're drawing a rectangle, which is what I wanted. Good news. So, but the rectangle is only on the upper right corner. Oh, it's because... No, I actually don't know why that's happening. Oh, empty string. Yeah, sorry. I was just doing something very dumb where I was like not even loading the shader program that I had written. Just forgot to fill in the box. Okay, so I'm setting my position to... Oh, that is another dumb basic mistake. Here we go. Full screen white rectangle. That's what I wanted. Now we can try to make it load values from our image that we're writing to. And hopefully this is the moment of truth. Let's make it... How do I read from an image? So image load store. I just call image load with a coordinate. And the coordinates will just be our UV values. But image coordinates are integers. You know what? I'm just going to make our UV coordinates integers also. So I'm changing my vertex formats to let's just do ints, assigned integers. So now I need to change these values. So since our image is 800 by 600, I need to just replace these with 800 and these with 600. And then finally, let's make this IVEC2. This should work. Oh, it doesn't need to be a vec4. I had that confused. Okay. So we are supposedly loading from the image. It doesn't look like anything's happening. Any one of a number of things could be going wrong. So I'm going to try using RenderDoc one more time. And maybe it will work this time. Okay, I actually think that it's probably literally because I'm streaming that I can't use RenderDoc, which is kind of frustrating, but we'll do it the hard way. Okay, so Charlie asks, do the vertex shaders operate on the vertexes and the fragment shaders operate on all the pixels? Yeah, so that's the right idea. So in this case, I have an array of 4 vertices that I am placing at the corners of the screen. and then 6 indices specifying the corners of the 2 triangles. So the vertex shader, this code, runs 4 times, once for each vertex in the corner of the screen. And then this, after that happens, so let me change this back to just drawing a white rectangle. So what's happening is, notice when I don't have that, it is the background color. So it's running this very simple computation once for every single pixel on the screen. Someone is going to see if OBS messes up RenderDoc locally. Thank you, that would be helpful to know. The reason OBS might get in the way is because it has to, I assume for screen capture, it has to be intercepting something at like a driver level, at a system level to stream things. And it's possible that could be interfering with what RenderDoc has to do. But yeah, I am very ignorant of the deep, scary world of graphics drivers and compositors, so I couldn't tell you. So yeah, this fragment shader is running for every pixel. So my goal, what I want to happen is, I want it to run for every pixel on the screen. You know what? I'm going to make sure my resolution is also 800 by 600. Anyway, so I'm running a compute shader which doesn't have anything to do with triangles or pixels. It's just pure threads, like it's just the kernel gets run for each thread. So I'm running a compute shader which writes into a buffer, and then I'm just trying to use a vertex and fragment shader to draw a rectangle that just kind of directly copies that onto the screen. Because as far as I know, you can't directly write onto the screen with compute shaders. You have to have that extra separation step. Okay. So, with resolution, I need to look up the gluten box. So for windowing, I'm using a Rust library called Gluten, which is kind of like it's like a Rust version of GLFW or SDL. Just opens a window and gives you an OpenGL context. Okay, this is what I need. And now our window, messed up. Now our window is the right size. So now it's the same size as our internal buffer that we're creating. So I need to look up how to use a compute shader, how to get your dispatch ID. So like I was mentioning earlier, oh, so Charlie's asking, do I not need the compute shader in the program : new pipeline? So I'll explain a bit more what I'm doing here. So I have 2 separate program pipelines. One of them is just purely the compute shader, and then the other one has the vertex and fragment shader. So this one is using the traditional graphics pipeline where it you feed in triangles, it runs the vertex shader, and then it maps those triangles onto pixels in the screen and then runs the fragment shader for each pixel. And I'm just using this in a pretty pass-through, boring way to just copy a buffer onto the screen. And then this compute shader, it kind of sidesteps that entire pipeline. It doesn't have anything to do with triangles or pixels. It's just a single stage compute shader that it's just writing to a buffer in memory, if that makes sense. So the way to tell if this is working would be, I'm going to try to write to every value in the buffer. Okay, actually, you know what? I'm going to reduce the amount of moving parts here. I'm going to comment out everything to do with the compute shader. I am purely going to see if I'm reading from the image correctly in the first place. I'm going to write the value 255 into this texture and then see if I can read from it in the fragment shader. It does not look like it because it's blank. I wonder if I can do this. Maybe there's a different image format that I can use R32 UI with. Image load store. Maybe image buffer works. Okay, I'm going to simplify this. I'm going to make it just an R8 texture. Just an 8-bit single channel texture. See if I can get that working. So where I set up my texture, I need to change it to GLR, GLRed, GLQ8, 255. So this will just be a single 8-bit texture with every value set to 255. And I'm just going to make this, I think, what are my layouts? R8 would be what I want, yeah. So R8. This also needs to be R8. Freezes. Interesting. No clue what I did. Oh, write only. I need to bind image texture as read only for this program. That makes sense. It makes sense that binding a write only texture and then reading from it would not work. It's also not R32 right now. It's R8. Okay, so I was able to capture frames with RenderDoc while doing a display capture recording with OBS. Yeah, who knows? I will figure it out later. It would be nice to have RenderDoc right now. All right, my goals have kind of shrunk for this stream. I basically just want to have writing some values to the buffer and then getting them on screen. I had all these ideas for like a particle system with moving around the particles, but we'll see how far we get. So we're binding our read-only image texture. I'm actually really confused as to why it's freezing. How far are we getting? So let me just put a print here to see if we're getting this far. We are not. So I assume we're getting to this point. Yeah, so it's freezing somewhere in this block. I'm generating a texture. I'm binding it as a texture 2D. And then I'm allocating an array for the image. And then I have a texture 2D. I am... Hey, Lewis. Oh, yeah. This is... Windows chose this for me. I never bothered to like find a cool wallpaper. Okay, so what could possibly be freezing in this block. Still freezing. So apparently it's the text image 2D call. Maybe unsigned int is the problem. And it should be byte. That's probably it. Yeah, we're getting a different error now. It's no longer freezing. Can't apply layout R32 UI to image type image 2D. So it should be an R8. Alright, so at least it's running. But image load should be giving us a value of 250. Should be giving us like the color full color value 1.0. So I don't know why it's not. We're binding the image texture. Maybe I don't need to do bind image texture. Maybe I can just do read it like a normal texture. So let's not try to do this as an image 2D. Let's do a sampler 2D. And then okay, a copy paste from some other code that I have. Active texture. You know what, that might be related. Anyway, let's try it this way. Bind texture. Alright, that's good. Now we need to use the regular texture sampling function instead of the image texture. So the difference is in OpenGL there's textures which are the old way of doing things that are just read-only. And then there are images which let you use image load store, which lets you write to the texture in a shader. I'm trying to go back to using just regular old textures to use something that I know works. So we know that we're drawing our rectangle, and it draws the color white if we don't have this. But somehow the texture is giving us zeros, because when we multiply it by our color, it's giving us fully transparent, because that's the background color. So gonna comment this out. So now we only have the stuff related to our uploading a texture and drawing a rectangle, and this should be easy to get right. I don't know why I'm not getting this right. Something I might be missing is the texture might not be complete, like I might not have specified the whole texture format, which is something I could discover with RenderDoc, so I sure wish I had RenderDoc. Kind of frustrating. So I think I should have a complete texture now. I think I'm specifying everything. Also, anyone who has any hypotheses, feel free to chime in, because I'm not doing well. But okay. So this is a known working program, so I can see what I'm doing there. Might try using get uniform location. Still nothing. Maybe I'll change UV back to a floating point vector instead of integers. Which means I need to have 1.0s here and 0.0s here. Oh yeah, Chicago, yeah. Okay, so DefaultXR asks, I'm curious, what resources did you learn to use graphics programming? So, a lot of random internet tutorials. For OpenGL specifically, I think there used to be this great tutorial, Neon Helium, for learning OpenGL. I think they probably have it updated to recent OpenGL, but it's from a long time ago, and when I read it, it was for like old style, but I think they have new stuff. So I think I would recommend Neon Helium. Okay, yeah, updated for 3.3 at least. And then there's another one that I was using a lot, which was there's OpenGL from scratch in Rust, I think, and which helped me because when you're using OpenGL from Rust, there's the whole layer of the FFI to see stuff you have to navigate, as well as OpenGL itself. If you're just using it from C, it's not as big a deal. So yeah, this one was nice. And then there's an excellent resource for kind of getting an understanding of what's actually happening in the hardware. Not on a like super nitty-gritty level, but it's called A Trip Through the Graphics Pipeline. I can post some links to all of these. Maybe I can post in chat or something, or I'll tweet it out. Anyway, this is really excellent if you want to get a deeper understanding of like what are the different stages of the pipeline, what are their vague performance characteristics, what tools do you have at your disposal, and then, so yeah, this is a really good resource. Neon Helium is a really good introductory resource, and this one was good for learning how to use it from Rust. Yeah, and then it's also good to just like find existing code bases on GitHub and plunder what you know is working from them and use it in your own stuff. Okay, so before Charlie asked what is UV provided by, so UV is a vertex attribute, So in my vertices, in my vertex struct here, I have a UV field, which is 2 floats. And I'm specifying it like this. So I have values between 0 and 1. And then right here, I specify the format of that vertex attribute. And then in my shader, I specify it as an input. Just found a mistake. Did not fix the problem. So yeah, it's an input to my vertex shader from a vertex attribute, and then I am setting, this is the way that you pass data on from your vertex shader to your fragment shader. So every vertex gets the vertex attributes, and then it outputs values for each pixel inside the triangles that it outputs to use. So in this case, I'm just setting my output FUV to my input UV. I should call it VUV. There we go. Great news. So yeah, I really recommend that one. Fabian Giesen, or Rigorous is his like demo scene username. Like he really knows his stuff. He's worked on different graphics hardware stuff as far as I know, and he's worked on, I may be remembering wrong, but he worked at, I think, Rad Game Tools, which they do like video playing stuff for console games. But yeah, so he really knows his stuff. There's this classic demo that he worked on with, there were some other guys in Farbrush. But yeah, this is just like really classic demo. Farbrush guys are just like really cool demo scene guys. So yeah, he actually has a series of blog posts going through that demo, the way they did like procedural meshes and other things like that. So that was really good to learn some ideas for doing things in a really procedural way. Because it's a 64K demo, so obviously they have to do all their meshes procedurally. Okay, so we've made progress. We are reading from the texture. Somewhere I should have been an hour ago, probably. Let's just make it read just the red channel. So yeah, it's drawing white, which is what we want because we filled it with 255. Just to show that we can, I'm going to try filling it with like 70 and see if it turns into gray instead. Yes, it does. So yeah, there we go. I might actually just use this as the alpha value. It's not working. Oh, I don't have blending on. I need to turn on forgot what the constant is called. Yeah, let's just do this. And I'm glad I'm using OpenGL because this kind of thing would also be happening, but 1,000 times worse if I were using Vulkan. And it would probably take the entirety of a 4-hour stream to get to where we are now. If that kind of problem came up, it would just take like 3 times as long to resolve. I have like, hey guys, welcome to the stream. If I were trying to use Vulkan, I have like a 3/4 of the way to a triangle on screen code base with Vulkan. If I had done a lot more homework for this and I had gotten it all working, it might have been worth using, but yeah. Okay, so I was going to change the value to 70 and see if it worked. Here we are. That looks like it should. So we're drawing a white rectangle at opacity of 70 out of 255 onto our dark blue background. So now we can try reintroducing the compute shader. So let's try using bind image texture, write only, setting it to the uniform in our compute shader, and then dispatch compute 1024. Let's just do one. Let's just spawn one thread. And then we need a memory barrier. Let's see if it works. Okay, so I can't really tell because there would be a single pixel in the upper left corner that would be white if this succeeded. So I'm going to make it instead be like 30-second pixel down. Okay, so it would be white, so it's not working. Maybe we just need to set it to 255. Let's just set all these 255, just for good measure. So, still blank. It will be a huge victory once I get a single white pixel on the screen from a compute shader. Okay, so I'm just going to go over this to make sure I'm not missing anything. So I am creating the compute shader. There are no errors there. I'm creating the texture. And then I'm using bind image texture. Let me go compare back to that image load store example that I had loaded up. So I'm calling bind image texture 0 texture 0 false 0. And I think they're just using a regular fragment shader to write to their image, because you can use image load store outside of compute shader. It's just a general thing you can use. So they're calling use program, draw elements. Their uniform 1i, image location is 0. Bind texture 0 to texture. Gen texture is bind texture, same thing I'm doing here. Texture content. Okay, I'm gonna try looking at the documentation for image load store. So when you call image store, it uses format conversion based on the format to bind image texture. So the format I'm giving bind image texture is single channel 8-bit red. Okay, I think what I need to use is uniform 1i text instead of uniform 1i 0. No, I think you bind it to slot 0. Let me compare with that example again. So yeah, image location is their uniform location. So maybe I should do that just to be sure. Just like I did for this one. Okay, still no luck. I'm trying to think what experiment I could do to figure out what aspect is working and what isn't. I guess I can just spam GL get error. See what happens. Again, I wish I had RenderDoc. Okay, so what is error 1280? There's probably something to learn from this. So error 1280 is invalid enum. An unacceptable value for any enumerated argument. Basically, I am trying to binary search to the program with GL get error. Okay, so the error is maybe in the program I'm creating? Yeah, maybe the compute shader is not even correctly being... Okay, so our first get error is returning 0, so there's no problem up here. This one is returning 1280, so somewhere in program creation. Honestly, maybe compute shader is the invalid thing. Let me just look up a compute shader example. So, shader source, compile shader, attach shader CS. He'll create shader. So if that were the problem, it would have an error right here. And it does. So apparently we're getting an error from passing GL compute shader. Why would that be happening? Oh no, I don't think we are. Get error. Yeah, we're fine. Okay, so it's successfully creating a compute shader. Check if it's compiling. It is. Okay, so the whole process of shader creation is working. But maybe here is the problem. Okay, we have found so somewhere between here I don't know what could be wrong. This is literally my shader error detection code that it's having an error in, which makes me mad. Okay, it's get program IV is what's happening. So if this returns invalid enum, if pname is not an accepted value, passing a compile status. Oh yeah, it shouldn't be compile status, it should be link status. There we go. There we go. My linking error detection code was wrong. Now we have an actual error, which is that compute info, no workgroup size is specified. So that gives us something to work with. So to go back to what a compute shader actually is, like I was explaining earlier, you write this program and it gets run n times where you specify the number, but it gets grouped into chunks, and those chunks share some memory so that they can collaborate more quickly than it's like a faster, more local memory rather than having to write out to main memory. So yeah, now let's just look at a compute shader example. So what we need is a layout declaration, which specifies our x, y, and z size. I think what we can do is just specify our local x size is 1, since we only have one invocation in the first place. There we go. I can get rid of all my get error calls. Honestly, in an actual program written by a competent person, I would probably have a systematic way to catching OpenGL errors. Thank you. Yeah. The chat pointed out that I wanted link status. If I had just been listening to chat, I would have seen it quicker. Okay. So now we have the compute shaders being run, or at least it's being linked. We still, hey, look at that. Look at that. Do you see that pixel? I don't know if it shows up on stream. Let me open up the magnifier. That pixel, you see? It worked. Our compute shader is running, and it is setting pixel 3232 to a value of 255, and then we're drawing a rectangle to the screen, which is reading from that texture and drawing one single pixel. Everywhere else the texture is transparent. Okay, we did it. Pogs in chat for the compute shader. Okay, so next thing I want to do, this is kind of what I wanted to have like an hour ago, but it happens. So now I have a compute shader. I'm gonna look up if it's fine to just have a work group size of 1. By default, the local sizes are 1. I'm not actually sure. I think it's fine if you just have 1. It just means you won't be able to share memory between invocations. But I'm not planning to do that yet anyway. So now let's up this to 1024. See if it's still working. It's still working. Yeah, so Charlie, actually let me explain why it's in the bottom left. So there's actually several points at which I could change where the coordinate system is happening. So like it is true that so OpenGL has how you specify where a triangle goes on the screen is you set GL position in the vertex shader right here. And so you get there's basically there's a cube referred to as clip space. So clip space is like anything outside the cube gets clipped off of the screen. So that's why it's called clip space. So your entire viewport that you're drawing to screen is -1 to 1 left to right, -1 to 1 bottom to top, and then it's -1 to 1 for your z values. I'm pretty sure DirectX and probably Metal, other APIs have 0 to 1 because that's better for floating point precision to have your more precise stuff at nearer z values rather than the way OpenGL did it. It's kind of sad. You waste all your precision at the middle distance. But anyway, so yeah, that's what clip space is. That's what your vertex shader should output is a 3-dimensional coordinate. There's a 4th coordinate for the purposes of perspective, but I'll ignore that for now. So you write your x and y coordinate, and in my case, my z coordinate is just 0 because I'm not doing anything in 3D. And then, so yeah, -1, -1 is in the bottom left. And then I decided to assign the value 0, 0 to my -1, -1 vertex. So this was like a choice I made to map the 0, 0 corner of a texture. Textures don't really have like an intrinsic direction to them because they're just data in memory with coordinates from 0, 0 to 1, 1. So like if I flipped around the 1s and 0s, I just need to flip the y's. So the v values, if I flip these vertically, then we should see, yeah, we see the, let me open a magnifier. So we should see our pixel in the upper left, which we do. I just minimize magnifier. Okay, so if that makes sense, there's like several stages where you map different coordinate systems to each other, and it just kind of worked out that it was in the bottom left. Up is positive in OpenGL, but you can change that in various ways. So like it's kind of up to you. It's not like enforced to be one way or the other, but yeah. Anyway. Okay. 87 minutes into the stream, I'm drawing 1 pixel. So now I'm going to see if I can draw a bunch of pixels. So right now, what is happening is 1024 invocations of the shader are all hammering this single pixel in the buffer with the value 255 redundantly. So I want them to use different locations instead. So the way I'll do that is there's a way to get your invocation ID it's GL workgroup ID. I believe, no, it's GL. Okay, here are the inputs. So we have a number of workgroups. So if the shader specifies workgroup size and the dispatch call specifies number of threads, then you can look up the number of workgroups inside the shader to see what what it ended up as. You can get the workgroup ID, you can get the local ID within the workgroup, and then what I care about right now is global invocation ID. So in our case, that should range from, I think, 0 to 1023. So let's see, let's just pass it in for the X values that were, let me check what type it is. What type is GL global invocation ID? It's a UVec3 because it's three-dimensional, like I was talking about. So we're just going to use the X value. I think it might need me to cast it to a signed. No, it's fine. Yeah, there we go. So now we have 1024 threads. Yeah, I mean, in this case, literally 1 pixel. Very anticlimactic. But now we have 1024 threads writing to 1024 pixels all in a row. So I'm kind of feeling bad with power at this point. I'm gonna look up, anybody know like a simple hash function to just give me random numbers from that ID? I don't know anything about hashes. I want just like the dumbest hash. Plug into a bunch of signs. That will work, yeah. Okay, so I could do I mean, I'm just gonna make it do like a sine wave. So let's just do sine and then like multiply it by 32, then cast it back to an int. Let me separate this out so it's a little clearer. Implicit cast from uint to int. I think that's this. There we go, yeah, okay, so now we're drawing a bunch of pixels in a very high frequency sine wave. Safe to say this is a very aliased sine wave. Okay, so we can slow down the sine wave and it'll look smoother. Yeah, there we go. Okay, so our x coordinate is just our invocation ID and our y coordinate is sine of our invocation ID. So yeah. Okay, I'll put exactly what's in chat. I need to figure out how to like use. Oh yeah, here we have my OBS chat client. Okay. I need to like learn how actual streamers do this kind of stuff. So this is going to be our y value. So if it's fract, we need to multiply it by 32. What is this actually? What is the co.xy? So so I need to have a two-dimensional thing here, I guess. I'm just gonna make it so that local let's dispatch this with x and y values, and then I can do global invocation ID right, that doesn't make sense. Let's flip it upside down. Okay. Oh, it's shader toy noise. Okay. Yeah, maybe I can just do like 16 by 16. See what happens. Yeah, there we go. Okay, so we have a little 16 by 16 grid and they're plugging into the noise. And then so we have, kind of doing this in a nonsensical way. I can instead write that value of that noise. So we can do our invocation ID as our coordinates. Plus 32. And then our value is going to be this. Image store UVec2. Yeah, right. Okay. I don't even need to use int anymore because it actually is a float. Cast from float to int. Yeah, done. What am I doing? I think it has to be IVEC2, so I have to turn this into an IVEC2 as well. Yeah, there we go. Okay, so let me up this to a lot of invocations again. There we go. I would say this is low quality noise in some ways, but maybe I'm using it wrong. Anyway, there we go. Got some noise. So let me put this into a little noise function. So I can use it if I want it. Alright, now I have a noise function. Okay. What should I do next? So, now that I actually have the basics working, with a compute shader, writing into a single channel texture, then drawing it to screen, I kind of want to change it to a 32-bit texture instead of 8-bit so that I have more precision. Because what I want to do is like a particle system that is additively blending into it. So I want more bit depth than just 8 bits. I'm not sure why it was letting me use a R32 UI. Okay, let's see if it breaks if I do the R32F again. So I'll change my texture to be an R32F texture. And I'll make these F32s as well. And then GL float. GL R32F. And that works just fine. Okay, so there's no problem. So now I'm gonna try. Does this noise work well for just one dimension? I guess it does, so I can just use a one-dimensional invocation with yeah, so I'd say that's fine. So let me change this back to dispatch compute. Let's just make this be doing one-dimensional 1024, and then we can make our coordinates be random. So yeah, let's make our. So what I want is a two-dimensional noise. I can just use the first row and the second row. So, okay. So I'm just going to sample the first and second rows of this noise function for our x and y values. I'm just going to write a value of 0.01. Wait, I'll just write a value of 1 for now. At locations x and y. So we're going to do ivec2 x times 800, just hard code in our resolution. So this will be a random point on the screen, and we're just storing the value of 1 to it. Wah, wah. Love a good old blank screen. I'm messing something up. Yeah, I'm not even getting my single pixel anymore. I'm writing 255 to 3232, and I'm not even getting that anymore. Okay, undo, undo, undo. Back to when it was working. Oh, okay, yeah. Chat points out that I put 0, which I think it's multiplicative. So that means I'm not invoking any threads anymore. That makes sense. Thank you for catching. Now I can redo those changes and it should work. So yeah, back to computing a random x and y, and then just bombing it with a value 1. There we go. Random points. Now what I really want to do is use an atomic operation. Because, okay, so what I'm doing right now is I'm just writing a value. So if anything else writes to the same pixel, it will overwrite it. But what I want instead is I want it to add to what's there. So I need to use, okay, image load store. Yeah, I did, yeah. ID.x. Like I'm doing it in a one-dimensional invocation now because I changed from having what I was doing before was having each pixel on the screen be a single thread and sampling a noise value for that pixel. But now what I'm doing is I just have a big long list of values and I'm choosing a random location for the value and scattering something into it. So yeah, I do intend for it to have, basically they're reading from the first and second rows of this like virtual noise texture, if that makes sense. So back to image load store atomic operations. Do I need it to be read write? Because it's write only, but I assume that atomics, I actually don't know. I'll just see if anything bad happens. Okay, so I want to do an atomic add. Oh, that's why I wanted it to be int before, because the atomics are only on ints. So atomics can only be used on images with R32I or R32UI. So this needs to be R32UI. I am going to search the internet for R32UI image 2D to see why it wasn't allowing me before. Does it need like so this example is using an atomic. It's UImage2D. That was all I needed. Okay. And then let me change the texture format to R32UI. Go back to, here's a U32. Unsigned ints in our texture. See if that compiles. Okay, so image store, yeah, we're not even going to use this anymore. We're going to use atomic add. Which, okay, returns the original value. And you put the thing you're trying to write to, and then the value you're trying to write to it. Want an example? So it takes 3 arguments for the coordinates. Oh yeah, this is, I'm looking at the compute shader local memory. I need to be looking at the atomic section. Okay. Oops. Image atomic add. Image coordinates data. That makes more sense. So image atomic add image coordinates data. Let's make this be like, let's make it 1. Okay. Does it take? It's a float. That's what my problem is. Let's do 1. Yeah. Okay. There we go. So it's not showing anything. Let's see if it will show. Let's put the max 32-bit value in there to see if the texture reads it properly. I think it might not be reading the texture properly. So, okay, texture format is R32UI, unsigned int, red. And our fragment shader samples the texture. It's getting zeros. Hey, Chemfig. What's up? So maybe this needs to be uSampler 2D. Let me put this as a float, see what happens. Oops. Yeah, nothing. So I'm not sure why this isn't working. Yeah, it's kind of confusing to me. This should be fine. So I don't know whether the compute shader is working, but I know that the fragment shader is not even working to draw the buffer yet. Yeah, let's try using uSampler 2D again, and then write ones to it. Yeah, it's an unsigned int, format as R32UI. Let's just comment out the compute and see if it's messing something up. Maybe. Okay, let's look on the wiki. How do you use a usampler 2D? I know I have one of those somewhere. Yeah, okay, so I guess I don't. I just want a basic example. Maybe I should use TexelFetch. TexelFetch requires the MIP level. Still give me zeros. So it's a R32. I have no clue what's going on. I just want to use my 32-bit texture. So that's so wrong. So I know it was working with the float texture with the image store. Nothing's working now. Oh, UImage2D. Yeah, okay, so we're back to something that works. Let me see if I can change it to an R32 UI texture. So what that does is just silently make it not do anything. Maybe I should spam some GL errors again. See what's going wrong. Alright, I'm still stuck. So I need it to be a unsigned int so that I can use atomics. But I'm just having a dumb problem where I can't, where it's not sampling the texture properly. Maybe I should use an image like this from the fragment shader again. Let's see if I can do it that way. So it's an R32 UI. Let's see if I can do it this way. So I'm binding it as read-only this time. And then I want to use image load instead of texture. So an image load takes integer coordinates instead of float, so I need to do so let's see if this works. Can't apply layout R32 UI. Oh yeah, UImage2D. Same mistake again. The values are maximum U32 value. Maybe I should make it 255 again. This is the worst one. I just have no idea what's going wrong. Going back to just using a regular texture. Time to spam GL errors. Nothing else to do. Alright, and this one happens on line 55. So there's an error in specifying the image. Default XR says that's what annoys me about graphics programming. It feels like a black box or like talking to a wall or something. Yeah, it's the payoff is very much not like talking to a wall. The payoff is like really unique to me in that like you're creating something visual that's happening in front of you. But when it's not working, there are ways to make it more interactive. Like I would say RenderDoc is the number one, or other graphics debuggers that you can get on different platforms make it a lot less like talking to a wall. But yeah, when it doesn't work, it just doesn't work. So R32 UI, GL red. So I've tracked down that my error is in the TextImage2D call, and it's 1282. So 1282 is invalid operation. Invalid operation is generative type is one of these formats, and format is not RGB. Well, I'm pretty sure it's not one of those formats. Oh, there's a whole load of these. Okay. Okay, so it's one of these errors. Type is not one of those. It's not one of those. Internal format is not a depth component. Format is not depth component. Not using depth component at all. Non-zero buffer object name. If data is not evenly divisible into the number of bytes needed to store in memory. talking about alignment? Okay. I saw a shader someone wrote that would basically plot out the value of its input. Oh, would it plot it like to the screen, or? I remember some API somewhere has basically a shader printf extension. You can literally just print stuff out. And there are I don't know if it's step by step, but there are shader debuggers where you can have a much nicer time trying to see what's going wrong. So yeah, there are some nice ways to debug, but kind of by default, it's hard to tell what's going wrong. GLPixel Unpack Buffer. I'm not using GLPixel Unpack Buffer, so yeah, I'm getting a 1282, which is an invalid operation. But it is none of the errors. So yeah, we're getting an invalid operation on text image 2D. There are some really cool debug visualizations. I'm not sure if I can remember right now. Here was a cool one. Yeah, wherever this comes from, Quantum Coins. Yeah, like this is a cool post where they use atomics in order to count how much overdraw there is from small triangles. So yeah, there's potential for very cool debug visualizations if you can draw something at all in the first place. I'm still getting that error. I'm so confused. It's an unsigned int, it's R32 UI, and I'm passing it a pointer to some U32s. And I know this code was working with the float texture. try some random stuff. Why is this error happening? Okay, maybe there's a way to get more detail about the error. Okay, I'm gonna see if Rust and OpenGL from scratch has a thing I can copy paste for getting an error string. Oh, this is already in the library that I'm using. The Rust OpenGL bindings. Oh, thank you. That'd be really helpful. One more try RenderDoc also. Okay, I think once I get this working, once I get a bunch of threads blasting atomics onto the screen, then I think I'm going to call it a stream and then continue next week. So once I get this bug fixed. This site is really nice. Somebody made docs.gl and it just has like searchable different versions. Okay. Chat has shared with me a paste bin. Oh yeah, this is just for the enum. So I kind of already have this. I've just been looking up the numbers manually. But I think there's a way to look up a string error. Whew. Okay, so we have localized our error to line 54. And line 54 is text image 2D. Our error is 1282. which is invalid operation. Okay, let me go over these arguments again. So we have target texture 2D, that should be fine. Level 0, internal format is R32UI, which should be fine, and the corresponding format is GLRed. Border 0. Oh, you know what? I think it's supposed to be GLRed. Integer. Yeah, no more error. We solved our error. It's because R32UI can't just be red, it has to be red integer. Okay, now it's all zeros. Let's see if 255 works. Once more, let's try usampler 2D. There we go. Okay, it's working again with an integer texture. This is all I needed was red integer instead of red. Yeah, so what we need to do is take this value. We're going to divide it by the max value for a 32-bit. I'll just copy paste this. How to arrange for U8. Oh, this is supposed to be U32. Yeah, okay. There we go. So what right now, I'm filling this texture up with like about half of the 4 billion maximum value for a 32-bit int. So this is a white rectangle drawn with half opacity. So now I'm going to reset the spec to 0. Make the compute shader add. So now the compute shader is doing these atomic adds of 1. So maybe I should divide it by like 10 instead. So it'll actually show up. Yeah, so if you look closely, you can see very faint values there. And there are actually a couple of double hits, because some of these are not fully dim, which is cool. What I'm going to do is greatly increase the number of compute shader. I'm going to do like a for loop with like 100 in here, and then each iteration I will get one from the next row. Okay, so it's obviously not a uniform distribution. We can work on a better noise function later, but I think it's pretty. If we increase it to 1,000, it gets denser. So yeah, basically we're just visualizing the noise function in a certain way. If I increase this, our number of compute invocations okay, so now we're kind of maxing out some of the values. Let's divide them by 100 instead of 10. Okay, so I think this is pretty. So this is a good basis for what I want to do, which is I want a bunch of particles that each add a small value to a pixel where they are at, or possibly they add to a little area of pixels if they take up more than one pixel. And I want to have a ton of particles like this, and then have some kind of physics engine moving them around, which I will probably do with another compute shader that runs over the particles. Yeah, this is, I think, a good basis for what I want to do. I'm trying to decide if I want to push further or call it a stream and then do more next week. Post opinions in chat. Should I keep going or call it a day? Alright, I think I'm gonna call it a day for now. Gonna get a screenshot of this guy. And yeah. Alright, I will hopefully have prettier images next week. Like actual particles. But I made a lot of progress today. I guess before closing up the stream, I'll go a little bit over my... Oh, Hubble. Okay. 2 things before ending the stream. I'm going to give an overview of what I'm planning to do with this project in the future, and then dog. Be right back. Hey, Hubble, want to come here? Want a treat? You want a peanut butter treat, bud? Hey, bud. I know you're sleepy, but do you want a treat? You want a treat? Oh my gosh, sleepyhead.
Wanna go? Papa, wanna go?
Yeah, it is.
Papa, do you wanna go?
Come here, buddy.
Wanna go see some friends on the computer?
Come here, bud. Come here. Get up, buddy. Come here, get a treat. Get a treat, buddy. Get up. Come here.
Maybe try opening his drawer.
His what?
His drawer.
You want one of these? Chicken stick? If you come out, you get one of these. Come here. Come on out, buddy. I'll just have to lift him.
It's gonna be sad.
Okay.
Oh, puppy. Poor puppy.
Okay.
Oh, poor puppy.
Alright, sorry about the delay. He was fast asleep. But here we go. Say hi to Twitch, Owl. Okay. Alright, so one last thing. I'm gonna go over my... Oh, here you go, buddy. Sorry. I'm gonna go over my goals for what I want to do with this in the future. So, I want to make a demo and submit it to a demo party in November. So this was kind of the preliminary stuff to get that working. So what I want to do is, let me show an example of a demo that uses compute shader rendering in a similar way to what I want to do. So this one is they're using the exact same technique as me in this demo. They just have a compute shader that's just blasting values into the buffer, additively. So they could do all these cool things like a particle gets blurred to a circle of confusion for like a depth of field effect. The thing that you can't do with this is have occlusion because everything adds. So if something's behind something else, it looks the same as if it's in front. So there are limitations, and what I eventually want to do is do some more complicated types of compute shader rendering, where I'm actually rendering triangles and have a Z buffer with occlusion. But I want to do things differently from the way that the GPU works, rather than just trying to recreate the regular GPU rendering pipeline in a compute shader. I want to do a pipeline that it's sort of similar to what the Unreal Engine version 5 demo was demonstrating with. They have a lot of tiny triangles in a way that would be slow, but I want to do it. Theirs is about like heavy duty photogrammetry scans, like very heavyweight acids with lots of detail. And what I want to do is, because it's a demo, I want to do everything procedurally. So I want to be able to, like, on the GPU, generate triangles for a tree, grass, things like that, and then dice them down to single pixel sized triangles, and use a compute shader to render those to the screen. And I think it can. There are some proof of concept papers that I've found that show that it can be a pretty fast way to render. So, yeah, for now, I'm just going to try to next week. Sorry about the noise. My neighbors are doing a lot of yard revamping during the pandemic. Anyway, next week I'm going to take this example, which is just drawing a bunch of random values into the buffer additively, and make it so that instead of random values, it's taking particle positions, and then I will have some kind of particle motion step that updates their positions every frame. Then I might try to do lighting, and I might try to do depth of field blur and motion blur, but that will be for future streams. So anyway, thank you everybody for watching. I'm pretty happy with how many people ended up watching this. Hopefully there would be less staring at a computer screen not knowing what's wrong, and more pretty pictures next time. But anyway, I think I'm going to do this regularly every Saturday at noon Central Time. So anyway, with that, I guess I'll sign off. Thanks for watching, guys.